Hello everyone, I'm Samya Shaman Sara and today I'm going to show you how I made my game called Color Road in assembly programming language. So let me first demonstrate the game to you. As you can see, there are three boxes of different colors moving downwards parallelly, and there's another box of the same color as one of the three. So that's the player, and that player has to find which box has the same color as it has and has to be in the same line so that it gets a score. And if it doesn't, then the game will be over, as you can see over here now. So let me now show you how I made this game. So the first thing that I wanted my game to show when I opened it was this image. So let me now show you how you can add image to your code. So this is the code for uploading an image. Let me make it very clear to you that this will work only if your image is a BMP file and if it has the resolution 320 by 200. Otherwise it won't work. So you can see that there are 5 procedures: open file, read header, read palette, copy bitmap, and then you have main procedure. Here you can see that I have first switched to graphic mode for uploading the image and then called the 5 procedures that I just stated. So these 5 procedures will remain the same if your image file matches the criteria that I just told. The only change that you need to make will be over here. This is the name of my image, which is test, and then I added the extension .bmp. So this is the only change you need to make to this code so that you can upload a file. So now you can upload the image. So let's run the code now. And here it is. So you can now upload an image. So let's move on to the next part, which is making the road and the boxes. So I will now make a procedure called road where I will draw all these things. So let's first switch to video mode, and then set pixels. As you can see that I have moved 150 to CX and 0 to DX because I want to start drawing from this place. Here DX is 0 and CX is 150 away from the start. If you want to start from anywhere else, you can add different values. So I will now draw the first line, which is this green line. So I will add a label L1. Here I have incremented the value of dx, which means dx will increment from 0 till 500 because I have compared the value of dx to 500, and till it's less than 500 it will keep doing this, so it's actually a loop. So after that is done, which means when the value of dx will be 500, I'll move 160 to cx and 0 to dx. So let's call the procedure road now. Save this and then run. So now you can see a green line over here. By repeating the same steps, I'll draw 4 more lines. So I'll add few more labels. So you can see here label 2, 3 and 4 are just the same as label 1. The only change is the value of CX. Like before starting label 2, I have moved 160 to CX and 0 to DX like I did in label 1. And then in label 2, I have moved 430 to CX because I want more gap to be in the middle. So let's just save it and see what happens. So you can see 4 lines over here. 2 are green and 2 are yellow. So the change of color is because I have moved 14 in AL for having yellow color and 2 in AL for having green color. You can add any other value and see which color you can get, or you can see the color code for getting the value you want. So we are done with drawing 4 lines, but we are yet to draw 3 more lines, as we can see here. But these lines are not just the same as we just drew. So these are a bit different. These are more like dots moving. So how can we do that? It's really easy, just like the one we did. So I will draw another line which is like dots. So the only change I have made is this: add dx 10, which means I am adding 10 to the value of dx every time in the loop. So that's why we will get to see the gaps. So let's save this. So let's run this now. So we can see that we have a line like dots over here. So we can draw the next 2 lines in the same way. So here are the lines. So our road is ready. So all we need to do now is draw the boxes. So now that we are done with making the road, we will draw these boxes, and we will start with the player, which is the red one in the middle. So let's start. In order to do that, we'll need few variables. So I'm declaring a few variables over here. P is a variable having the value 12 because P is actually the color of the player. And P position is 310 because I am storing the position of the player, which is 310, and R is 310 and RA is 270, because I want to start drawing from 310 to 270. Let me explain this. This is the position 310 and this is the position 270. So I'll make a line from 310 to 270. That's why I'm storing these two values in R and RA. As I'm starting from 310, I'm storing the value 310 as the position of the player right now. So we will now create a procedure for the player. Right after the procedure road. We will now move the value of R to register CX because we want to draw a line from there. Now here's a label called label A, where I'm moving the value of P in AL, which is defining the red color of the box, and then I'm decrementing the value of CX till it reaches the value of RA. RA is 270, like we know that we defined it. So we will now call the procedure player and see what happens. Save this. You can see a red line over here. This is the part of the box that we are making right now. So we will make the rest in the same way. So we will add another loop which is label 9. So here we are incrementing the value of dx till it reaches 475. Let me tell you that the value of dx is 440 right now, as we assigned 440 to dx at the end of the procedure road. So let's save this and run. So here's another line. So we will now add the rest of the two sides. So here you can see that the box is complete. But our task hasn't completed yet. We need to add two more lines over here, which are we need to move 400 to cx and a variable d to dx. We haven't defined the value of the variable d yet, so we will now do that. Here we will declare it. We are assigning 10 to the variable d because we want the next drawing to start from this position. So we are now done with making the player. We will now draw the other three boxes. So let's declare another procedure. Naming this obstacles. Here the first thing that I'll do is move 400 to cx and d to dx, and then I'll draw the three boxes. So here is the first obstacle box. I have drawn this in the same way I have drawn the player, but here are a few exceptions, like as you can see O1, D2, we don't know what these are. So these are the variables that I have declared. So here are these variables. D2 has the value 45 and O1 has 9, O2 has 12 and O3 has 11. Well, these O1, O2 and O3 are actually holding the values for the color of the boxes, and here are the position variables where I'm storing the position of the three boxes. So in order to draw the first box, what I have done is moved the color of the box in air, then decremented the value of cx. Cx is right now at 400, and I'm decrementing it till it reaches 360, which means basically drawing this, and I'm starting from here and I'm drawing till it reaches this place. In the same way I have drawn the other lines and completed the box. So I'll now save it and run. So before running this, we need to call the procedure, save this and then run. As you can see that we have a blue box over here. So we are done with drawing another obstacle, and in the same manner we will draw the other two boxes now. Now the obstacle number 2, where I have moved the value of O2 in AL, which is red, and then changed the values of CX and DS and drawn the lines. And the same for the third obstacle. So I'll now save it and run. So let's now run this. So here are the 3 boxes and are here. So we are now done with drawing everything that we need. So we will now move these obstacles. So in order to make the boxes move, we need to do few things, and they are, first of all, we need to clear the screen so that everything becomes black, and then we will draw everything we have just drawn in a new place, so it will look like it has moved. So the first thing that we are going to do is clear the screen, and we will add a label. We'll now add a procedure called obs black. Here I'm just moving the values, moving 410 to CX and DX, and then pushing the value of DX because I'll be using this value later. So I've moved 0CH to AH so that the screen turns black, and I have moved 2 to AL so that the pointer becomes green. So if I call this procedure, the screen will turn black. So let me show you that. As we said that in order to move everything, we will draw them and then keep them for some time and then clear the screen and then draw them at a new position. But there's another thing that we need to add, which is delay, because if we don't add delay, then there might occur a situation where the viewer might not be able to capture the movements and we might just see the last position. So we will add delay. So we will add a macro called delay over here. So here it is. We will first push the values of all the registers because we don't want the values to be changed. So this is the main part of the macro delay. Here we are moving some values to AX, CX and DX. This is actually causing the delay. So by calling this, we will waste some of our time and this will make the viewer capture the movement properly. So after that, we will change the values by adding another macro called value. So what we are doing in this macro is adding 50 to D and D2. And why are we doing this is when we add 50 to D and D2, we will be just changing these positions, and the position, the value of the dx will be 50 more, which means they will be 50 times away than they were before. So these boxes will move to this place after that. So now that we are done with making these labels, we will now add all these in a label and then call them. So we will create a procedure ops loop, and here we will call all the procedures. So first we will call the obstacle, then we will add delay, then we will clear the screen by calling ops black, then we will call the road, the player, and the value. So this will change the values, and then we will call the obstacle again and repeat the same thing. So let's just remove these and call the procedure ops loop. Save it, and now we will so as we can see that it just moved. So you can see that after calling the obstacle thrice, it has reached this position, but I want this to reach here. So after trying many times, I figured out that I need to call this 9 times so that it reaches here. You can also use a loop rather than just calling them, but I did this by calling it 9 times. So I have called these procedures 9 times, and then I will run this. So here you can see it's moving and it has reached till the player and it has now stopped. So we are done with our work almost, but we still need to do few more things, which are the movements of the player, and then we need to change the colors also. So we will now do that. So we have made the boxes on top move, but we haven't made the player move yet because the player can't move the way the obstacle boxes move. We need to make the player move only if the player has pressed any key. So we will need a macro called key to check whether the player has pressed any key or not. So we will add it here after the macro value. So here we will first check if any key has been pressed or not. If it hasn't been pressed, then we won't waste any time and then jump exit. But if the player has pressed any key, which means this won't be false and j not equals 0, it will jump to the label key pressed. So we will now write the label key pressed, where we will check if any key has been pressed or not. So here is the key pressed label. So here we are going to check the input. So we will compare it So if the value that we have got is R, which means if the R key has been pressed, then it will jump to a label called right of, and if the key that's been pressed is L, then it will jump to another label which is left. So let's just write what is going to be in left and right. So if the player presses L, the player has to move left. But we need to check one more thing, which is it can't go out of the boundary. So what we are going to check is that the current position of the player. So it can be either here or here. Only then it can move left. Otherwise it will stay just where it was. So we will now check where it actually is right now. So in the label left top, we will compare the value of R to 310. So as we know that we had stored the position of the player in R, so we will compare it to 310. If it is at 310, so when it's equal, it will jump to another label, and if it's not, then it will compare its value to 400. So these are the two places that the player can be if it has to move left. So after that, we will add these two labels ry and rz. When the R will be 310, it will move to this label ry, and when it will be 400, it will move to rz. We are doing this because when R will be 310, it means it's here, and when R will be 400, the player will be here. So we will now go back to the code. So when it goes to the label ry, it will move 230 to R. 230 means R is right now, the player is right now in this place, and when it goes to the label left top, it will check if its position is 310 or not, and when it will find that its position is 310, it will change its position to 230 and it will be here. So here it is in ry, and RA has been changed to 190 and the position has been changed to 230, and then we will jump to exit. And if this thing doesn't happen, then we will go to this label which is RZ, where we will move 310 to R and 270 to RA, which means the player is in this position right now, and we will put this here in the same way we did for this position. We will do the similar things for the right key also. So these things will be done if the player presses R. There's another thing that has to be done, which is we need to make these labels local. As we know that if we add labels in a macro, we need to make them local. So we will make them local in this way. So we will now call this macro key after every time we call delay. So that if any position is changed, we can draw the player in a new position. So we will now save it and then run. So let's run this. You can see that it has moved left. Now it has moved right. So we have now brought the obstacles to the bottom. So what we need to do now is check whether the colors are same or not. So in order to check that, we'll need another loop, and before checking that, we will move 0 to D, and D2 will be 35, so that the next time we call this goes back to the same position. So we will now call the procedure check. So we will now create the procedure check. So what we are going to do here is take the position of the player, which is P position, and then compare it to the positions of all three other boxes, which are O1, O2 and O3. As you can see that I have moved the values in a register and then compared it to those values. So if the position of the player is equal to the position of obstacle 1, which means the first box, and then it will jump to OB1, and if it matches to the second box's position, then it will go jump to the label OB2, and similarly OB3. So what we have in OB1 to in OB1, we are taking the value of the color of the player and the color of the first box, which is P and O1. So if these colors match, then the score will be added, and if they don't, then the game will be over. And we will do the similar things for O2 and O3. So after the checking whether this will jump to the label SC or to game over. SC means score will be added, and game over means the game will be over, no more scores. So we will now add the SC label. In this label, we will add 1 to this variable res, which this is the variable where we are storing the scores, and here's the message. This message is actually the score. We will add it here once. Here the first message is score and the second message is game over. So after adding the score, we will print it. This message is score, and then we will print the result just next to the message store. So after that, we will store the values back and then call ops loop again. Ops loop is the loop where we were making the obstacles move. So we will do that again. So this is how we are making the obstacles move again and again from top to bottom. So if the colors don't match, we need to check if colors don't match, then we need to jump to another label which is called game over. Here we will print another message, but this one is not scored. This is the game over message, and then we will print the result in this way. And I need to show you something, that here we are adding character 0 to dx, which means we are actually converting the character into a number, because when we are storing this value in dx, we are actually storing the character. So by adding 0 or 48, we will be converting it to a number. So our score adding and game over part is also done. But there's one thing that we haven't done yet, which is changing the colors, because we don't want the obstacles to be the same color and make the game so boring that we will always know where the right one is. So we will make the colors random and change them. So here in sc label, before calling the ops loop, we will call another macro, which is color, and this macro will change the color of the obstacles. So we will now add the color macro. Here it is. So what we are doing here is just simply swapping. We are swapping the values of the colors of box 1, 2 and 3, and that's why they will be changed after every time they reach the bottom of the screen. So let's save it and then run. So let's run this. So you can see it's moving left, now it will move right. You can see the score here. And now it will show game over. So we're done with our game. So this was my assembly programming language project, and I hope you liked it. Thank you.